All right, let's continue along. Our next functional group, guys, are ketones. They have, again, carbonyl group. Remember, carbonyl is that C double bond O. It's located, though, on an interior carbon. This is how it differs from an aldehyde, okay? It's similar, but it's on the inside. So aldehydes are on something like this. Like we saw, this was the one we did in the last video, okay? But, guys, a ketone would not be on the end. It would have to be on the middle guy. All right, so the example that we have here is 2-pentanone. So like aldehydes, right, they change the ending from E to al. Ketones change it to -one at the end, okay? And we must cite the location of the C double bond O in this one. Whereas with the aldehyde, we didn't have to say, hey, what carbon was on, because it's always on an end one, so it would always be number 1. But here we've got to make sure we understand that we have to identify where that carbonyl is. So pentanone, so again, start with your main chain. So here's, all right, 5 for pent. This one, again, is in table R, but doesn't matter if we start from the right side or the left side. So 1, 2, that's where our double bond is going to go. Oops, notice what I just did there, right? How many bonds can a carbon have? It can only have 4. So make sure you know that, hey, it's only 4 bonds. All right, so here we go. This is where it's different. Where in aldehyde, guys, when we had pentanal, it was on the end carbon. Now we have 2-pentanone. It's on an interior carbon. All right, so this could either be 2-pentanone or 3-pentanone would be the only other possible combination we could have of this. So pause the video. You guys go ahead and try naming this guy. So remember, start with your main chain. So I've got 3 carbons. So I know that it's going to be propanone. How do I know that it's a ketone? Right here, that carbonyl group, right, is on an interior carbon, so it's propanone. I'm going to rewrite this so that you can see the O-N-E. And then the last thing, guys, is you would identify where is that ketone group. So it's 2-propanone, all right? Number 6, organic acids. They have a carboxyl group. Notice that's a little bit different. This is something I would encourage you guys to write down in your reference tables as well. So carbonyl groups are just C double bond O's. A carboxyl group, though, is an acid. So it's got the double bond O, but it's also got OH. Okay, so it's got a double bond O and an OH. They are found at terminal carbons, guys. So instead of E as our name, we have oic, then acid. Oic, then acid. These guys will generate what type of ions in solution? You should know this. This is a reminder, guys, a refresher, because they're acids. Acids produce H+ ions in solution, which means these are going to be electrolytes as well. So naming or drawing the structure, going from a name to a structure as propanoic acid. This is, again, in table R, but just break it down. Prop means 3 carbons. Excuse me, my acid has to come with a carboxyl group at the end on one of the terminal ones. So this is what it would look like right there. Double bond O with an OH hanging off. Again, you don't have to memorize these functional groups. They give them to you in table R. You guys go ahead and try to name this guy. So there's only 1 carbon. That would make this methanoic acid. Methanoic acid. Okay? Continuing on, group number 7, ester. Not ether or ether. Okay, very similar, but this is ester. How I remember, I still remember that to this day, is that my chemistry teacher, she said the ester bunny, right? Because bunnies lay ether eggs. Or I'm sorry, oh, wow, I just messed that up. The ether bunny, ethers, lay ester eggs. Eggs, right? Because 2 oxygens. I know that's really corny and cheesy, guys, but if that helps you remember the difference, one of the differences, again, you have table R. So the ether bunny, if you look at an ether, where you have this kind of sticking off here, right? You could kind of draw it to make it look like a bunny if you have an ether, right? So it's like, oh, yeah, something like that. And then you have these O's, whatever. That's a corny, cheesy way. If that doesn't work for you, ignore what I just said. Use table R. These guys right here in the middle, C double bond O with an O next to it, connecting parent chains. So remember, guys, these are going to be internal. All right, these are going to be internal. This side is what we call the parent chain. Okay, the parent chain. So whatever's connected over here on the right has to go first, like it's a branch. Okay. The hydrocarbon chain single bonded to the oxygen is the branch. You name it as you would any other branch. These guys have very fragrant aromas. So a lot of stuff that can smell tend to be esters. So keep that in mind too. They might ask you, well, what smells kind of, fruity or, have these different ones like wintergreen? Esters are the ones that have an aroma to them. So ethyl butanoate. So notice how we changed the end of the main chain, guys, the parent chain, to OAte. So start with that one, butanoate. So that's 4 carbons. Then I'm going to hit my double bond, oxygen, and my O. And then ethyl is going to be on the other side, just like that. Okay, break it down into pieces. Break it down into pieces. So here we go. I'm going to do this one together. So I'm going to start with my main parent chain. Again, look for the double bond O. The one that has those carbons to it, count that up. 1, 2, 3. So this is going to be propanoate at the end. And then now I'm going to look at my other branch on the other side of my oxygen. That's going to be methyl. So I want you guys to try this next one on your own. Pause the video and see how you do. So propyl methanoate. So I'm going to start with this guy first, my parent chain. So meth is just going to be 1 carbon. And then propyl, it would be 3 carbons. So yes, this one does matter, guys. Ethers, it doesn't matter which one comes first, typically alphabetical, but here it's not alphabetical. The parent chain has to come last, that gets the O8 ending, and then the branch chain comes first in the name. All right, so keep that in mind. All right, next group, amines. All right, N is alone with only hydrogens seen within the carbon chain. So this is where an amine is where you have a nitrogen group hanging off of a carbon. So the amine group can be a branch off the parent chain, like a methyl branch. Number the carbon with the amine group, just like we've done before. It can also be buried within a carbon chain. Name exactly as the same as you would an ether, except substitute the word amine for the ether. So it can either be like an alkane group, or it could be like an ether. All right, so we're going to kind of see both. So let's start with this one. Okay, propanamine, okay, where it says if you put amine, if it's buried, okay, amine is also going to be at the end. So we can't just look at amine, but since we don't have 2 names, guys, like an ether, like ethyl, propyl, or butyl, methyl, or something like that, we know that's just one long chain. So propanamine, we're going to start with our prop. So we have 3 carbons. The amine is going to come off the end, so it's NH2. Note, guys, that nitrogen can have 3 bonds. Okay? So if it's bonded to one thing, it's going to have NH2, but it could also be bonded to a couple of things and just have one H hanging off of it. Where carbon, right, can have 4, nitrogen can only have 3 bonds. So that would be 1 propanamine. Let's take a look at the next one. So we've got 1, 2, 3, 4, 5 carbons is my big one. So I'm going to call that pentanamine, because I see, hey, it's got an NH group. All right, it's got that nitrogen. But now, where's that nitrogen hanging off of? Oh, it's on my second carbon, so it's 2 pentanamine. Pentamine, something like that. Now, this next one is a little bit different, right? Ethyl methylamine. Ethyl methylamine. So we know that this is more like an ether, so that's going to be buried. Okay, this amine group is not just hanging off like a branch; it's buried within our chain. So on one side, I've got 2 carbons. On the other side, I have 1 carbon. I could have flipped it around, guys, and put the ethyl group over here on the right. It doesn't matter. Okay, it does not matter one bit. All right, and that's what we would have. Again, note that the nitrogen can only have 3 bonds. All right. Moving on to our last functional group. Oh, I'm sorry. Before we do that, guys, these things called amino acids. You've probably heard of those from biology. Okay, the organic molecules containing both a carboxyl and an amine group. Don't worry about naming them. Just be able to recognize them. they contain additional functional groups, guys. So there's 2 functional groups within one structure. So if you take a look, here's our general formula. Here's that N, and here's that carboxyl group, okay? So it's the amine and the acid. Same thing here. We've got our acid right here, and we've got our amine group right there. Threonine, same thing. We've got our acid group here, and we've got this guy here, and we also have an alcohol there, guys. So if you see more than one functional group in a structure, note that it's an amino acid. This is something you've got to memorize, okay? Chances aren't likely, like they'll probably come out and tell you, hey, this is an amino acid, find or circle the amine group within the amino acid or circle the carboxyl group. You've got to know the difference between those, but you won't ever have to draw a structure of these. Our last functional group, guys, are amides. So these are similar to amines, but now you've got this group here at the terminal position, okay? Or it's connecting a parent chain to a branch. So again, use your reference table, use table R. Let's take a look, propanamide. So here we go, 3, and then it's going to be my group at the end if we take a look at what the functional group looks like. Okay, so we could have a branch, guys, hanging off of this N, but in this case it doesn't say anything, so it would be, named like an ether, but this is just propanamide, so it's just a straight chain with a terminal group, all right, for our amide. I would encourage you guys to maybe pause the video and try butanamide on your own. All right, so take a look. My main chain is bute, so that's 4 carbons. And then I'm going to have it connected. My last carbon would have that group that looks like this, and then fill in my other lines for my hydrogens. Butanamide. Now, notice the difference, guys. This is where we have a parent chain and a branch. This is where we have 2 names. It's not just one word. So methyl and ethanamide. This guy is your parent chain, meaning it's going to have the 2 carbons that are attached to a nitrogen, and the carboxyl group is on your main chain here. So the one that has amide, guys, is your parent chain. Now we'll have a methyl group hanging off of our nitrogen, and that's what it would look like. Okay? Pause the video, try this one on your own. So propanamide, start with 3 for prop, and there's where my amide group is going to be. Fill all those in. And then I've got an ethyl hanging off of that nitrogen, like so. Guys, I know I just threw a lot at you in those 2 videos, okay? Take some time. I've got lots of practice sheets. Use table R. You've got to get familiar with it, okay? You don't have to be experts. You've just got to be able to identify what functional groups are there. Take time and practice this, because you will be asked at least 1 question about functional groups on your Regents exam, so make sure you are familiar with them. If you have questions, please don't hesitate. Call me over. Till next time, I'll see you later.